Great. So yesterday, one of my questions to you was if I have a 5-digit number, or 5 digits, and I want to select a 3-digit house number. I said using the fundamental counting principle, all right, you put the number of decisions down in terms of blanks, and then you put the number of options in those blanks. So I have 3 blanks here, correct? The first blank, how many digits do I have a choice of? 5, and then 4, and then 3, which gave me 60 ways in which I could do this if I had no restrictions on the question. Okay? Not too difficult. What I didn't tell you is that we are talking about a permutation right now. There are 2 things that we're going to look at. We're going to look at a permutation and we're going to look at a combination. Now, permutation is a selection of n objects in which order is going to be important. That means that we have to list them in the order that they're in. Now, a permutation we write as NPR. Take out your calculators, please. On your calculator, I want you to first type in 5. 5 on there. Now I want you to go to math, go across to the probability, the PRB, go down on it and find NPR, hit enter, put a 3 in there, and hit equals. 60? Good. So,
wait a second. I put 5 and then NPR and then I hit equal and it gives me an error.
you just put a 3 in after.
Okay.
Got 60?
Yeah.
Okay. So, what NPR is this equation right here. So it calculates n factorial over n minus r factorial. N represents the number of selections I have possible, the number of options. R represents the number of decisions that I'm going to make. Okay? They write it a little bit different in here. The number of permutations the number of permutations of R objects chosen from a set of n different objects is NPR. So what that calculator just calculated for you is 5 factorial over 5 minus 3 factorial, which is equal to 5 factorial over 2 factorial. So far we understand what's happening here? Okay, now, what does a factorial button mean again, or what does factorial mean?
All the numbers like below it.
Right,
Yeah.
multiply. That's right. So if I expand this out, I get 5 times 4 times 3 times 2 times 1 on top, and on the bottom, oops, I have 2 times 1, correct? So just by canceling, what am I left with? 5 times 4 times 3. This is what we call a permutation. You're going to use a permutation. This is the most important thing that you need to remember. You're going to use a permutation when you are selecting R objects from N, and order is important. That word has to be emphasized to you, because when we use combinations, we select R from N, but we do not order them. So you have to remember that. Okay, so our permutation order is important. Permutation order is important. If repetition is allowed, the number of permutations that can be created from a set of n different objects is n to the r. We don't necessarily need to use that. Now let's look at the 3 examples that they have provided for us. How many different permutations are there of 5 objects from a set of 7 different objects if repetition is not allowed? Okay, so yes, you have the calculator. You can use the calculator for this. So this would be 7p5. All right, don't put take your calculator out just yet. Okay, let's practice right now. That is 7 factorial over 7 minus 5 factorial. Excuse me. Okay, which is 7 factorial over 2 factorial, right? Which, if I cancel out, is going to leave me with 7 times 6 times 5 times 4 times 3. That's what it's going to leave me with. So you can multiply that out in your calculator, or you could use the 7 NPR button, 5, and hit equals. And what do you get?
2,500.
Yeah.
Oh, why would you stop at 3?
Because, good question. If I expand this, that's what I have on top for 7 factorial, right? And on the bottom, what do I have?
Oh, okay.
Okay, that's a great question. All right, that leaves us with 7 times 6 times 5 times 4 times 3. So if you didn't have your calculator, that's what you'd be left with. All right? And again, that's if no repetition is allowed. That means you're selecting 5 objects without reusing any of them. Marta is writing a science fiction story in which the serial number of a starship can have 1, 2, or 3 different letters, followed always by 4 different numerals. How many different starship serial numbers are possible? Okay. So the first thing we have to discuss is the serial number could have 5 digits, 6 digits,
Mr. Froese, please.
or 7 digits.
Mr. Froese.
Okay? The first digit would be a letter and then 4 numerals. The second one would be 2 letters, 4 digits, 3 letters, 4 digits. So we have cases now. So let's look at this and see what it actually looks like. So she is serial number that can have 1, 2, or 3 different letters, followed by always 4 different numerals. So I've got 1. So this is going to be 1 letter, 2, 3, and 4. Okay, so how many letters are there in the alphabet? 26. So this is 26 times. It says different numerals. So 0 to 9, what's my first blank? How many do I have to choose from? 10. I have to include 0, right? Okay, so 10, 9, 8, 7. So there's the first one. Now what happens if I have this? This is going to stay the same. Okay, choice of 26, choice of 25, 26, 25, 24. So if I have 1 letter and 4 numbers, that's the number of ways in which I can choose it. If I have 2 letters that are different and 4 numbers. If I have 3 letters and 4 numbers. those are the number of ways in which I can do that. After I'm done multiplying, I add those together. Now, put your calculators down, because there's actually an easier way to do this question. All right, first of all, does anybody not understand that? Because I have to have 4 different numerals.
What could it be? 1, 2, 3, 4. No, those are options.
These are how many I have to choose from.
Oh, I see.
0 to 9?
Yeah.
Digits 0 to 9?
Yes, you have 10 options the first
Yeah.
time, 9 options the second time.
Yes.
Yeah, I see.
Yes.
Yeah.
Okay, good question. Anybody else not understanding that? So, an example, just hypothetically, A, 0, 1, 2, 3. That would be an example of one possibility out of 26 times 10 times 9 times 8 times 7, right? So there is a lot of possibilities here. Now, I have just showed you the easy, most basic way of doing this question. If you ran into a problem on the exam and you wrote it out like this, you get 100% as long as you could add those all together. But there is a quicker way to do this question, because I have 26 choices for the letters, correct?
Yeah.
Now I'm choosing 4 digits from 10. So I could write this as 10P4. Right? So far, so good. In case 2, I'm choosing 2 digits out of 2 letters out of 26 and 10P4. And then in case 3, it'd be 26P3 times 10P4. And then you would add them together. So either way, you would get the same answer. In the first one, I have a choice of 1 of 26 digits. Right? So there's 26 choices. In the second one, I have to choose 2 of those letters from 26. In the third one, I have to choose 3 of those letters from 26. Go ahead.
No, sorry. Sometimes I just get confused with the N and the R.
The larger number's always got to go first.
Always.
Always, because that's the amount you can select from.
So N is the number you can select from, and
R is the number that you select, how many you're selecting from N. Okay? When you're writing out NPR or NCR, which we're going to do after the next lesson, it's always going to be the higher number and the lower number. Calculator won't do it any other way. It'll give you an error otherwise. So you really cannot get that wrong, as long as you know how many objects you have total to select from and how many of those objects you actually need to select from.
So the N and P are the values, right?
Yeah.
Or not the N and the N and R.
Right. So the N is the total number of letters in the alphabet, which is 26. And of those 26, I need to choose 2 of them for my serial number.
Okay.
In this one, I need to choose 3 of them for my serial number.
So if it was you needed 1, you would.
I could go 26. Sorry. I know I should have done that, but I could have done this.
Does it make a difference?
No.
Okay.
Because this is a great question too, because if I have this, right, that's 26 factorial over 26 subtract 1 factorial, right?
Mm-hmm.
What's 26 subtract 1?
25.
So I have 26 factorial over 25 factorial, right?
Mm-hmm.
If I expand 26, that's 26 times 25 factorial over 25 factorial, and those would cancel. So I end up with just 26.
Okay.
Okay? Other questions?
So then you would just add them all up, right? Together?
Yeah. What you have to add each of these 3 cases up
So
to
it
get
would
your
be
final
more.
answer. So it's probably a large number. What is it?
82 million.
82,031,040.
Yep.
Okay. Questions so far?
So for the 25 factorial, you just went, oh yeah, because the factorial is everything less. So why didn't you go 26 times 25 times 24?
I did. I basically did, right?
Oh yeah, I see. Just until you can count off the 25.
Yes.
Oh yeah, I see.
Yeah.
I said yeah.
Okay. All right. Move that off the wall. Your desks. A set of 6 numbered symbol cards includes 3 cards with circles, 2 cards with squares, and 1 card with a kite. How many ways are there to lay out the cards in a single row so that circle cards are 2nd, 4th, and 6th from the left? Okay. So now they're basically just trying to throw a curveball at you with restriction. How many cards are there total?
52.
No, in this question.
Oh.
So how many decisions? If I'm arranging 6 things in a row, how many decisions do I have to make? 6 decisions, right? So I'm going to make 6 blanks.
So blank represents number of decision, each decision.
Yes. Okay? All right. What is the restriction that's put on it? Right. So the circle cards have to be in position in the 2nd, the 4th, and the 6th. So here's the 2nd position. That needs to be a circle. The 4th needs to be a circle. And the 6th needs to be a circle. Right? So far, so good? Okay. How many choices do I have for the circle cards here? 3. Here? 2. Here? 1. Okay, so now I've got 3 other cards to choose from. Yes.
Did you go 1, 2, 3, or do you always go from like left to right?
When you're picking your first pick, how many do you have to choose from? Right? Would it matter if I went 3 times 2 times 1 or 1 times 2 times 3? Sure. Like 1, because I'm multiplying all of this, right?
Yeah.
So if I go 1 times 2 times 3, same as 3 times 2 times 1. Correct? Okay? So there are 3 ways to place a circle card in position 2, 2 ways in 4, and 1 way in position 6. So the remaining cards can be placed in any permutation into positions P1, P3, and P5. So how many do I have a choice from for the first one then? What do I have left here? A kite and 2 squares, correct?
Yeah.
So how many do I have a choice of here? 3, 2, 1. So the fundamental counting principle is probably the easiest method you can use for any of these questions. Any of these questions. That's all there is to this question. 3 times 3, 9, 9 times 2, 18, 18 times 2, 36. There's 36 ways in which I can do this. Fundamental counting principle is just draw yourself blanks and put the numbers in them. And your restrictions we just write on the bottom so that we know what we're doing. That's the easiest way to do that question. All right? Girls. Okay. Did we get to the end of 4.2 yesterday? You're supposed to. There's only 4 questions. Are we done to the end of 4.1? So we've got 4 questions in 4.2 to finish. Okay. And then we've got all 4.3 to do, which is 10 questions. Again, these questions shouldn't take too long. I'm going to, let's look at page 100. I'm just going to introduce it right now for those that can get done quick enough. All right. If I ask you to arrange the letters of the word seam, S-E-A-M, I want to know how many ways I can arrange those letters. All right? So that I have something different each time. So how many ways?
Does it have to be like an actual word?
No,
Just
just have,
like
just, yeah.
24.
24, 16. Okay? How many letters do I have here?
4.
1, 2, 3, 4. How many choices do I have for the first one?
4.
Second,
3.
third, 2, and 1, which works out to 24. Okay? 24 ways in which I can do it. I'm not worried about what they spell. There's just 24 ways in which I can arrange those letters, right? We all agree?
Yeah.
We all follow what I did there. Again, I put blanks down for the number of decisions, and then I put the number in each, how many ways I can choose those, right? Okay, what about this guy? Same thing?
No.
Different?
It's repetitive.
Right. Absolutely correct. There's going to be an issue, right? Because the E's are the same, and I can't distinguish between the E's. So I'm not going to have as many ways in order to arrange them without them actually repeating themselves. So this is what we say is permutations with like objects. And how we treat it is simply we take the number of ways in which I can arrange them, and I divide it by the number of like objects. So we figured out up here that there was 4 factorial ways of arranging this, right? Now I have 2 letters that are the same, so I'm going to divide by that value right there. So I divide by the number of letters that are the same. Now, what does this represent? Well, that represents the number of ways in which I can take the letters E and arrange them separately. EE, there's 2 ways in which I could do it. So if it was EA, there'd be 2 ways times 1 way in which I can do it. So the value on the bottom is always the number of like terms. So I get 4 factorial over 2 factorial, which works out to 12 ways. There's half as many ways of arranging this word as there is this word, or those letters, I guess. These letters compared to those letters, because I have the same letter. You get this? Okay? That's not right, is it? There's no T.
Yeah, there is a Sue and
that's
right. No, there's no.
Sam and
Does kiss at the church hall every Monday afternoon.
I thought there was no
When
dog.
y'all were that.
Yeah.
I didn't know there was a
Yeah,
I didn't know there was
Whose class?
Miss Schweitzer's.
Yeah.
Yeah.
She
Wow.
did learn that.
Sue and Sam
There's a
kiss at church.
At the church every Wednesday.
Wow. Okay. Learned something new myself. Okay. Number of letters in that word now.
Lots.
This is math class. Lots is not an answer.
12.
12 letters. 12 factorial. That'd be the number of ways in which I can arrange a 12-letter word in which all the letters were different. Now I have to divide by the like ones. So how many S's are there?
2.
So I divide by 2 factorial. How many A's are there?
3.
3 factorial. Are there any other letters that are the same in there? No? Okay. So on your calculator, and watching the board for 1 second, make sure you do that.
Are we modifying? Yeah.
So again, where did you get the 2 and the 3?
There's 2 S's and 3 A's.
So they're asking for S's and A's.
No, I'm asking for the ones that are the same,
Oh, okay.
that are like terms.
Okay.
Oh,
What is the answer? Read out the answer because
Shoot.
I want to make sure that everybody knows how to do this on the calculator correctly.
I think I'm wrong.
Will it mess it up if I don't do brackets?
Yes.
I have the same one.
I have to redo it because I did.
Okay, what'd you get, Chris?
I got,
I don't even know how to say
399168000.
I got the same thing as you guys.
CJ?
39,916,800.
916,000?
Yeah.
800?
Yeah, I got the same thing.
Okay. If you do not use brackets, you won't get the same answer. You'll get a much larger answer than that. Anybody not get that answer?
It works both ways.
Anybody not get that answer? Everybody's good?
Number.
Okay, I just want to make sure. Take a look at the example 1, page 100. How many different arrangements are possible? So you have those 10 objects there, right? So how many arrangements are possible? 10 factorial over
2 factorial, 3 factorial, and 5 factorial.
That's right. Okay, without our calculators now. Without our calculators, I want you to watch. I'm going to take the two largest numbers and cancel them down. So I'm going to have 10 times 9 times 8 times 7 times 6. And I'm going to cancel the 5 factorial out. So now that leaves me with 2 times 1 and 3 times 2 times 1. Okay, so again, I don't have a calculator, let's say. All right, 3 times 2, that cancels with 6. That cancels, leaves me with 4. So now I'm left with 10 times 9 times 4 times 7. And so I could use my calculator at that point. But all I'm doing is just working it down. What's the problem?
You lost me when you canceled out the 6 when you took off the 3 times 2.
What's 3 times 2?
6.
Times 1 is? 6 divided by 6 is?
1. Yeah. Got it now.
Okay, so I'm canceling anything that's on the bottom that's also on the top. Right? Just to make math easier.
So if you can times two numbers on the bottom and then equal the one on the top, you can cancel.
Yeah.
So why
It's reducing fractions. Right? How do you reduce this fraction? 4 over 6. Right? So I'm taking whatever's on the bottom and canceling with whatever's on the top. Right? Same thing. Yes, Brandon.
Why do you only go till 6? Like 10 times 9 times 8?
Because I canceled out the 5 factorial that was below.
I'm sorry, don't yell.
Anybody else? Okay. You got lots to do today. I want for sure to the end of 4.3 finished for tomorrow. That's good. Yeah.